Hope everyone is doing all right.
Yes, doing well, thank you.
Good, good,
Yes, thank you.
good. So I wanted to use this time to talk a little bit about the problem we were discussing last time about about how to collect the collect the purses. Because I wasn't sure if the methodology that I was employing, the implications of the methodology were understood. So Tomislav, you were proposing a list like collector, which changes the synchronization semantics of rholang, and I want to avoid that at all costs. So the trick that I propose in the Discord is, you you know, we're in a particular scope, and you need to walk up the scope until you have the enough visibility to be able to do synchronization. So the thing is that we know that that scope exists because at the worst, the scope is the block, because the block knows the total number of deploys. And so the proposal to make a deploy that has information about the number of deploys is just making the rholang execution aware of the environment, right? So it doesn't change rholang's semantics. We're just there's just some environmental variables that haven't been filled in. It's sort of like the deploy ID. You're making rholang aware of environmental information. And that's the difference, right? You don't have to change rholang semantics or execution. You're just giving some environmental information that wasn't available, and that's actually in that's in the spirit of rholang, right? It's a part of reflection, is to be able to make more of the environment available at processing time. Does that make sense?
Yes, yes, because we know that we will push something to a channel some amount of time, some number of times, and later we want to know this number, right?
That's correct.
So that we can collect. Yeah.
That's exactly right. And that number shows up at the block scope level.
Mm-hmm.
Right. So that's the connection amongst all of them. Yeah. So that's really all I wanted to chat about. There's a methodology, right, which is a part of the reflection methodology, which is to increase the scope of information that's available in the environment, and package that up and make that available to rholang at the time of processing.
And in that sense, we are escaping of making conflicts, because we don't have inside the rholang, we are not using some kind of channel for this kind of synchronization.
That's correct. That's
to count or something. Yeah.
Correct. Yeah. Exactly. Good. All right. So we've got that solved. I don't actually have anything else prepared. If there are any other questions or comments, there's lots of fun stuff I want to talk about, but it's not yet prepared. Like one thing I've been thinking about is I didn't realize that the renormalization group has been utilized to reason about phase transitions. So I was in trying to understand that, in my own terms, I've been formalizing the notion of scale in row calculus. So you can, the thing about the renormalization group is that it helps you deal with scale invariant phenomena. So so there's a way to talk about a notion of scale objectively in row calculus, right? So if you have a process P, then if you take the name of that process, that's at a different scale or scope, that's at a different level than P. P can never contain a name that refers to P. That's by design. That's the in order to do that, you go one calculus out. You can define names that are fixed points, but that's a new calculus. So you can use this property to define notions of levels. So I want to talk about that at some point. But do you understand the intuition?
Yes, I think I do. Yeah.
Cool. So there's you can build out recursive definitions that give you notions of scale invariant phenomena, right? So a process that looks like itself at every scale. And the notion of annihilation is also related to notions of scale. All right. Any questions?
Can I ask you? Yeah,
Yeah.
I have a question. I was listening some lectures about spinners, and they were. This is like a little too hard for me, but they were connecting this to Clifford algebra, and they were saying that this is in Clifford algebra they have some kind of combinatorial flavor. This kind of structure where they were representing this as some kind of on the bottom is the scalar, then 3 vectors, then 3 bivectors, then 3 vectors, and so why you mentioned this in the context of the row calculus, and can you maybe say something about that and how to understand Clifford algebra and why is interesting?
So Clifford algebra gives a different way of encoding geometric information. And what they don't stop. You can have as you have a grade lowering and a grade raising operation. So you can go up or down in terms of the dimensionality of the gadgets that you're looking at, and they have a nice algebraic structure in the sense that you've got analogs of inner and outer product, and with those you can easily describe phenomena like rotation and those kinds of things. The quaternions, so the spinners, if memory serves, the spinners are actually just another name for quaternions, and the quaternions are part of 4 division algebras, right? So you've got the reals, you've got the complexes, you've got the quaternions, and you've got the octonions, and that's it. That's the end of the story. Clifford algebras formalize geometry in a different way, and it's uniform, and it doesn't stop at 4. If that makes sense. So
this is definitely new information. So yeah, I need to process it.
Okay, and so the thing that's interesting, the reason I mentioned Clifford algebras is that you can apply OSLF to Clifford algebras. So all of the geometric descriptive power, you can lift it another level, right? Because you can now make queries Clifford algebra terms describe geometry, and then predicates built on top of Clifford algebras now describe, you know, um, collections of geometries, so possible geometries. So you can now say, you know, is the I'm looking for a geometry that looks like this, or like this, or like this, you know, and all of them share this property. And you see what I'm saying? Right. So it becomes a more powerful device than just Clifford algebras.
So I would need to understand how can I encode some type of geometry in Clifford algebra?
Yeah.
If I want to.
Yeah, exactly. So there's two references. There's Doran and Lazenby's geometric algebra, which is a pretty good introduction. And then there's David Hestenes's stuff on geometric algebra. Now, gosh, one of the functional guys, Kmet, argued to me that he doesn't like the Clifford algebras because the syntactic overhead is pretty large as you go up in dimensions. So that's the that's a potential drawback.
Oh, I see.
Yeah.
Okay, thanks.
Sure.
Can I also ask you in connection to the first thing that you're talking about, and how we collect purses? So right now, purses are not exposed from Revolt. So Revolt is keeping a purse inside.
Yeah. You should have.
But I have more.
Purse is like a building block. It should. I mean, you could have a specific collection of instances of purses that are hidden inside the Rev Vault, but the notion of purse itself should be exposed, so people can build with purses rather than having to rebuild that idea all the time.
So this idea of purse. So right now there is one point where. Which is strange for me. So when we are doing the transfer, we are splitting the purse, which is inside Revolt, as the holding amount of balance that we have.
Yeah.
Then we split the purse, and then we use this purse to transfer to another Revolt.
Yeah.
Or another purse.
Yeah.
So, but in this moment of splitting, we already removed this amount of rev from source Revolt, and so right now this operation is atomic because this purse is not available to anyone. But if we expose this purse to anyone, or so that we can collect it in a validator channel. I'm not sure how to ensure atomicity of this transfer.
You just have to make sure that the splitting happens in a scope that only is visible to the parties you want to see it.
Yes, yeah, exactly. And I was thinking, is the notion of purse, maybe it should be the intent of transfer. So instead of doing the splitting, we are just saying, this amount. If you want to, so if I give you my purse with some amount, you can do the transfer in some atomic or some scope where this is completely atomic, but this is still not done until you really not initiate this transfer from the purse.
I'm sorry, what? Can you say that a different way? I understood everything except the last little bit.
So instead of in the moment of splitting, we are not subtracting this amount directly from the source purse, but just to give some kind of in that case, purse means whoever have this purse can do the transfer, but this transfer didn't happen on this still moment. So for example, this is I'm thinking about the purse as some kind of permission to execute transaction. But if you never do anything with this purse, nothing will happen. I will still have my own all of my reps on my rep count.
I don't remember. I'd have to look at the purse code to verify that. I'm not sure that that's the intended semantics. You can always ask Mike. He's the one that designed it.
I think, Tomislav, are you saying that this thing we were thinking about, we can delay the summing until later would cause problems, because until you actually take out at that point in time the balances, there is a possibility of double spending?
No, I was basically thinking if we expose this purse so that we can collect all of them, and how it's working right now is when we do the splitting, we are basically automatically taking this amount of rep. But if something happened with this purse and we don't do anything, we will not catch that. We will lose the revs, but we will never return it back in that sense. So this is what I'm thinking. So maybe this is the reason why they didn't expose purse outside of the revolt, to have this like in a scope.
Yeah, it's the scope. The scope management is essential, right? So you just have to make sure that you have a scope that that includes the parties that are involved in the transfer, and excludes anyone who can't, who might interfere.
I'm really interested in situation where I want to pay to someone for some kind of NFT or something. I want to give my purse, but I want to exchange something for this, right? We want to have some direct transfer. So how can I check if someone...
You're trying to use the purse to do something else, right? You're trying to generalize the use of the purse.
Yes, basically. Yeah.
Right. You're trying to make the purse now be a part of an atomic swap. I give you something, you give me something.
For example, yeah.
Yeah. You could probably with scope management, you could have two purses, split them both, right? And you give the bottom to the right hand side and the top to the left hand side. The bottom of the left to the right and the top of the right to the left. You could do that.
I'm not sure that I'm following.
Imagine you got two purses, a left and a right, and you split both into top and bottom.
And the idea, we want to transfer something from one to another, right? This is the idea.
Well, I thought you wanted to do a swap.
I mean, I want to transfer some revs from one to another. This is my.
That's all. But that can be done inside a vault, right?
But
you just make a new vault, not right? Just make an instance of the vault construct, and you do exactly what's being done today when we transfer rev.
But how do I know when? How can I do this in some kind of transactional way, so that when someone takes something from my purse or make a transfer, that immediately I can check if I get some kind of unforgeable name that I paid with this transaction. This is something that Dan was make a comments how this is difficult right now.
I guess I'm not sure I understand the requirements. I mean the rev vault functions to transfer rev, right? That's exactly what it does.
But I don't want to transfer rev immediately. I want to be sure that first of all, I want to transfer only a part of my balance,
right? But that's
And
what
I
the
want to
Rev,
be sure.
that's what the Rev Vault does, right? People have been using that for over a year.
Yes, but I want to be sure that how can I be sure that I'm exchanging something for my rep? So if I pay something, maybe I will not receive anything, and I cannot do anything about it.
Okay, but that's what I was saying. So let's imagine we have two purses. One contains resource A and the other contains resource B.
Mhm, mhm.
Okay, so now I have the function of splitting. So the A purse I split and the B purse I split. Right, and now
Okay.
I want a swap. I want to give the top of the A purse to the B and the bottom of the B purse to the A.
Okay, okay, I see, I see. So you're assuming that we have a generalized way of purse, so that we can put anything inside, not only like numbers.
Yeah.
Mhm, mhm.
And that's all you can do, right? That's the best you can do using purse technology.
Mhm, mhm.
I mean,
Okay.
I think the general problem here is that if we're talking about operations on the purse, but there's also the integrity constraints on the purse or the vault. And I'm not sure if we're better off with simplifying the integrity constraints or whether we're better off separating the integrity constraints. But maybe that's a slightly broader thing, because anybody can put any rules that they want to say, this is the integrity of my transaction. And then we have to say, well, the purse semantics and the vault semantics, do they support that kind of an integrity constraint or not, right?
Well, I'm just assuming that the simplest form of transaction is, you know, you get NA for MB. Right? There's an exchange rate between the two. And so you have to respect that exchange rate. And anything else, anything beyond that is starting to get really, really, fancy. And I'm not sure what we're doing anymore.
Mhm, mhm. I see.
And the purse is designed to support linear exchanges. So with linear exchanges, you can have multipliers and an offset. Right? But that's it.
I
If you're
see.
gonna
I see.
if you're gonna do something else, then you kind of left the realm of what you do with purses. At least that's the way I think about it.
So,
And
so basically,
and notice that I'm not suggesting, even with the swap thing, I'm not suggesting that you can put anything in purses. All we're saying is that the purses have a notion of unit associated with them, right?
mhm.
So the numbers in the purse are associated with a unit. So if I've got M things in a given purse, it's it's M units of it's M A's, and if I have N things, I have N B's, right? And I'm exchanging A's for B's.
Mhm, mhm. So basically, yeah, I was also thinking about this atomic swap, and so this means that we create our source purse, give it to someone, and then we need to check if this purse is used. Basically, is it empty right now, and that give us information if the swap really happened.
That's not a swap. You just gave away a purse. A swap is I get something and I give something.
Hmm. So how can we
And if you just want to transfer a rev from one party to another, or transfer anything from one party to another, you have the rev vault. If you want to get something for something that you've given, that's a new functionality. Right? So what you want to do is to guarantee that at the time I get something, you got something, right? The time Alice gets something, Bob got something. That's not the same as Bob gives Alice a piece of his purse.
Okay, but yeah, for this purpose, I was thinking more like we are giving someone some kind of permission to get the purse or to get the swap, but it must give us something back so that we can immediately check as a part of this atomic swap.
Yeah, I'm not
Something
sure.
like that.
I'm not sure what you mean by swap. I'm still not following what you mean by swap. So the definition of the word swap is, you know, party A gets something from party B, and party B gets something from party A.
Yeah, this is what I'm thinking. Yeah.
Oh, okay, all right. Because you keep saying party A gives a split of its purse to party B, but party A didn't get anything.
Yeah, and this split, this is why I was thinking that this split should not immediately give the reps inside, but just the permission to do this if something
Yeah,
does happen.
but see, I don't think that that's the right way to do it. What I'm saying is, you party B and A both have purses. They both split and they both exchange. Right?
And to Mislav, I would say that you don't have to give some sort of permissions. You just have to create another vault. You can create as many as you want in rholang. So if you have 20 units, just create a vault, put 10 in it, and give the auth key to the party you trust.
And this party can basically take your rev and not do anything, right?
Yes, so you have to trust it, and this is how Archain token works. If you trust this this Archain token deployment, then you have confidence that the swap will occur between your revs and the FTs or NFTs that you want to purchase.
So I'm thinking how to how to create something so that you don't need to trust, so that you give something, and then this atomic operation, as part of this atomic operation, it will execute something that we can check that is okay, and then the atomic operation will continue and finish. So that in the middle of atomic operation we have our code that can check. Oh, I will at the end of this swap I will have what I want for my revs.
Yes, so
Not sure if this makes sense.
I would say that this is a exchange capability with bids and asks at the layer 1 of rholang, what you're describing.
Can you clarify?
What you're describing is a decentralized exchange, the way I understand it, because you have some A's or B's, and you can either, if you have revs, you can propose ask. You can say, hey, I want to purchase 2 A's for 10 dusts each. And if you have the resources, the NFTs or FTs, you can say, hey, I want to sell them for this price. And you don't have to trust any third-party rholang deployment, simply because those features are provided by rholang. And this is not the case at the moment, of course. This is why I did Archain token. It's because we need this second layer, like rholang capabilities.
Yeah, I'm basically thinking about that. Yeah. So I'm not sure if this must be provided as a part of revolt or purse, or
No,
yeah.
no. If you want to do something like that, it's outside of the functionality of Vault. So it's like a Vault plus.
Okay, I need to think about it. If yeah, I was not completely sure that this is possible to implement if we need to give to someone this authentication key.
Well, so in Raphael's proposal, there's trust, and in my proposal, there's no trust. Then you can implement it with joins, right? On both sides, you have to have both pieces of information. So you can't get to the next state until both sides have both pieces of information.
Oh, I see. So this is basically this intermediate step where both sides can check. Yes, I have what I need.
Yes.
And just allow to continue, and then both sides will get to the end, and this will be like a complete transaction.
Correct. Exactly.
Okay. So with per validator channel, I was thinking what is the easiest and the less computational way to collect transactions, or what do we need to change to be able to do this? Because right now we cannot collect purses, and I mean we can create a bunch of red bolts, but I would like to not to do this. Because we will create a bunch of records in the tree hash map, which just make things slower. So if we can avoid this, it would be
okay. I'll think about an optimizations.
okay. Thanks.
All right. Thanks, everyone. I'll see many of you in the dev stand-up. And yeah, good chat.
Yes.
All
Thanks.
right. Sure.
Bye-bye.
Bye.